Welcome to the Maintainable Software Podcast, where we speak with seasoned practitioners who have helped organizations work past the problems often associated with technical debt and legacy code. I'm your host, Robby Russell. On this episode, we are joined by Steve Pulling, which rhymes with bowling, who is a senior technical consultant for Excelon Development based out of Grand Rapids, Michigan. Steve Pulling, thanks for joining us on Maintainable.
Thank you very much. I appreciate the invitation.
Yeah. So given your vast experience in the industry, I'm sure you've played a part in a number of software projects that accumulated some technical debt.
That is an accurate statement. I've been instrumental in creating technical debt, as well as in paying it down, or in the cases where the technical debt got so bad, we engaged in rewrites, which is the metaphorical equivalent of declaring bankruptcy.
And actually, on that metaphor, was the metaphor technical debt used early on in your career? Do you remember that being something that was consistently used, or is that something that came about later on in your career?
I would say in the first 10 or 15 years, what we talked about mostly was there was this vague sense of unease. Something was wrong with the code base. You'd say that's a crufty mess, or there's a lot of spaghetti code, or you'd communicate with managers and you'd say, it's wrong and it needs to be fixed. The reason why technical debt as a metaphor is so effective is it speaks from the engineer to the manager who's generally got a financial background in terms of he understands. You and I understand as developers, when you have a code base with a lot of problems in it, it's a tax on your productivity. Your velocity of your team will be lower. And what happens is that tax on your productivity is just like when you're living your life and you've got a house payment and a car payment and a payment, Visa payment, and all these other things. These are taxes. It's a continual tax on your ability to make it in life. And the same way, you've got problems in your code base that you haven't gotten rid of. You're just bleeding all the time. And explaining that bleeding all the time from wounds that don't heal. You can't talk like that to a manager who's looking at numbers, who's looking at dollars and cents, but he can't understand debt. And he understands that debt accumulates with time. He understands compound interest. And if you can take the notion of compound interest and debt and then phrase problems in your code base in those terms, you'll be more effective in communicating. And that's why I think the metaphor has taken hold. There are other metaphors about bad software, like a sand pile. Like what happens is you drop a sand pile, it gets too steep, and then at some unknown chaotic point, it collapses, and then suddenly it's a big deal. And likewise, you've seen the situation where you've got problems in your code base and you're just maintaining, put a little bit more, then one feature more, and then boom, you've got yourself a mess on the hands. And your velocity drops to zero and you've got to clean up a bunch of stuff. That chaotic behavior of the sand pile is something not captured by the technical debt metaphor, but it's harder to communicate to the bosses. Technical debt is one of these things that we can understand. It accumulates, it gets worse, and we want to pay it down.
What led you to the industry in the first place?
Oh, I started out as a math major, and basically had no interest in computers because they had involved putting holes in pieces of paper, really tedious and annoying. And so I said, I'm just going to be a mathematician. I don't want to deal with these computers. But then suddenly I get a job that has a full screen editor. And this is like decades before the term developer experience became part of the nomenclature. But suddenly the improvement of developer experience from just having punch cards or paper tape up to a full screen editor, that was enough to say, oh, I can handle this. I can do this. In fact, dang it, I'm pretty good at it. So I found out that the master's in mathematics was a slog, but the master's in computer science was a cakewalk. So I said, I guess I'm better suited to this stuff.
Nice. And what sort of what languages were they using back then at that point?
Well, I started out in Fortran and then quickly segued into a couple of languages you've never heard of, and then into C, Pascal, of course. Did a lot of work in C, then C++. And lately, the language I'm most enthralled with, I'm sort of in love with it right now, is F#. The move to declarative, or I should say functional programming, I think it's a big deal because probably it's just romance on my part because I started out in the philosophy, the mathematics, and all of the functional programming seems to engage some of the earlier mathematical aspects of my training.
Interesting. Yeah, I haven't dove too far into some of the functional languages at this point. I've been primarily in the object-oriented world for quite a while. And so
F# is a good way of doing it because you're still in the .NET space.
what is your take on how open source has evolved over the years? I mean, did you feel that there was a time when you're learning and when you're working in your teams, if you go back several decades, there must have been some level of sharing of ideas and approaches amongst the community somehow, or was everything kind of isolated within companies?
At one point, the only thing you could do is that you could find there was a fairly limited amount of open source going on, a lot of proprietary stuff. And that really was a tax on productivity. You've got the fundamentalists like Richard Stallman, who says, thou shalt not have anything that isn't open source. I can appreciate that. In fact, he's been sort of vindicated by some of the behaviors we've seen on the part of Google and Facebook. But nevertheless, my own path has been sort of trying to be as pragmatic as possible and avoiding becoming a fundamentalist myself in terms of being so extreme that I use GitHub. I like GitHub. I like being able to go to clone somebody's repo and study the code. If I have to study code to understand how something works, it's a real nightmare to try to grasp something with just the documentation.
It's very true. Yeah, it's because you mentioned working with like in the .NET space and even knowing how Microsoft's drastically changed their tune over the years. So now that .NET's like open source, and it's been interesting even in my shorter career of only a couple of decades just to see that transition where I can find old blog posts that I've written where I think I was maybe a little bit non-pragmatic, but calling companies like Microsoft out about how that was challenging because I needed to learn by looking at other code and I couldn't do that necessarily. And I couldn't necessarily have access to getting all the certifications and stuff like that, or to sign up for your Microsoft developer to have access to all their tools and stuff, which I had access at some previous jobs. And so I had worked with .NET at one point, but there was a point of me like pushing that away. Like, nope, I'm going down this open source route. And then, 15 years later, it's like, oh, now we're all back and playing together again. And so I think it's actually probably a good thing.
You've got a Linux kernel sitting in the middle of Windows 10.
Yeah.
But I was really angry by the fact that I couldn't run Docker inside Windows 10 Home. Now that's being fixed, but next year, I guess you'll be able to run Windows 10 Home and have Docker containers inside because it has virtualization going. If Windows is shipping with a Linux kernel, that tells you what's happened to the world.
Yeah, we've come a long ways. Let's see. So over the years, what types of processes have you and your teams implemented to help keep tab on your code's technical debt? Like, I'm assuming, was that just like, oh, we've been complaining about this issue for a while, maybe we should do something about it? Or did you find some ways and processes that you were able to kind of repeat and kind of keep on top of that a bit?
Any code base over time will grow and hopefully get better. Unfortunately, most times code bases get worse. And they get worse until they get so bad that the clunkiness of the code, the velocity of development goes down so much that that's basically accumulated technical debt. People know better how to accumulate technical debt than to pay it down. And most times that pattern that I've seen has been, okay, we're going to let the code get cruftier and cruftier and cruftier. All the original devs are going to leave the company. They can now become scapegoats. We'll then push for a rewrite, which is basically going to be this, and they're going to make the exact same mistakes because every bit of cruft in your code was a bug fix. And the trouble is that when you look at the development pattern of red-green refactor, I drank the test-driven development Kool-Aid a decade ago, and it changed my life. If you're doing red-green refactor, your code base is not going to have that happen. If you just do red-green in terms of your unit tests and forget to do the refactor, your technical debt will accumulate. What happens then is if you have code that does not have complete, effective unit test coverage, when you try to make any change to the code or refactoring to the code, you're in trouble because what if you break it? So what happens is that fear of breaking it causes you to make architectural decisions that, okay, I know I could fix this data structure, but I just need to get in, make this one little change and get out. And so as a result, you take, and it's sort of like taking a lump of clay and putting it on top of the side of the code base. And what happens is you do this a number of times and your code base loses all cohesion. And that's how technical debt, after the initial development could have been done in a leisurely fashion, with infinite resources and be perfectly pristine. But That pattern I just described will allow technical debt to increase over time until the code base becomes unmaintainable.
When you would work in your teams where you follow that model of red, green, refactor, I'm assuming your teams have needed to provide some sort of estimates of some degree to provide to stakeholders and how that fits into a timeline. Did you account for potential refactoring time as part of that estimate? I'm just thinking like on a day-to-day level for a developer when they're working, say, a sprint, and they're like, or they get into something like, oh, I didn't realize I was going to need to potentially do some refactoring in this area. I may not have the time for that right now. So I often wonder how that's the point, because they didn't really think about, I'm going to get the thing done. I can build that. That seems simple enough. But, I may need to actually do some refactoring or spend some more time to make sure this is kind of integrating really well into the overall system.
I think what happens is you have to always say, well, let's back up. Remember the old TV show House? He said everybody lies. Managers lie to devs. Devs lie to themselves. So I'm not going to lie to you about how long the job's going to take until after I've lied to myself that it's going to take X when it's really going to take X plus 10%. So what happens is in the context of all this lying, and then what you got to do is you got to live with the promises that you made, then you're behind the 8 ball. So the best thing to do is measure yourself in terms of how well you're estimating. And if you're estimating too aggressively, put in a bit of margin. You should have margin anyway. But the greater uncertainty in terms of your estimate, the greater the margin you should have. And by planning with margin and with everybody knowing there's some margin here. I've got one friend of mine, he was notorious. He would always pad any estimate he gave you because he knew that he wanted to have that little bit of extra time to fix the problems. You get a task to do X, and then you say, wow, I got to do this thing here on the edge. Or I've got to do a little bit of architectural work, or I've got to do a little bit of, and your boss is, tapping his watch saying, come on, let's go. We've got to get this done. And he's got a legitimate point. Engineers like to play in sandboxes. So what happens is that you've got to be able to stay focused on task. And that's going to have you going off on all directions and wasting a lot of time. So you've got to be very focused and saying, I'm going to solve this problem and I'm going to have, a bit of margin. Maybe it's a Friday afternoon project to think about what are the architectural improvements that I need to make? How can I make them? It's like the Boy Scouts. How can I curate the code to make it better tomorrow than it was yesterday?
Right. I think that's a good practical thing to think about in terms of the red green refactoring. Are there other types of processes that you've seen put in place where, let's say you come into an existing code application as a team and realizing we have a lot of technical debt, it's not documented very well. How do we start setting up a good process where we don't have a good test suite to rely on just yet? And where are some good starting points for a team to start moving that boulder in the right direction?
Oftentimes, when you've got a code base that's in this situation, they'll be talking about declaring bankruptcy and they're talking about a rewrite.
Mm-hmm. That is one option. Yeah.
And every time I've seen a rewrite, it's been, give me the new shiny, should be just like the old, except, and then new features. So what happens is that 9/10 of your application is just like the old. Well, what's the old? And if you can find the requirements documents from 15 years ago, great. Okay? But generally, those are not available. If you can find the tests cases from long ago, that's great. One of the best projects I was on, I was able to find the original DOS specifications for the software I was writing. And those test cases were just as good on the third rewrite of the same software. So one is that you've got to think in terms of how am I going to test this mess for the new one? If you've got the test cases, if you've got the documentation, count yourself very lucky. God was good to you that day. You should have bought lottery tickets. If that's not the case, which is the case most of the time, you just got this software and you say, make the new shiny work the same as the old. But you don't have any docs, you don't have any whatever. The best thing you can do is go back into the old, retrieve the code out of its previous state, and then without making any changes, add a scripting interface. Or if there is a scripting interface, add some mechanism to be able to run the thing in an automated fashion. Run the old in an automated fashion. If you were lucky and it was in a batch processing thing, you're great. If it was an interactive system, as many Windows systems were back then, you can just go through the UI. And what I did very successfully was I put a scripting interface on top of the UI. So I intercepted all of the events that were coming through and then just put a script there that would essentially emit those events in the same order. So that way I could run the old in a script. And that way I could say, okay, I'm going to run the old and I'm going to run the new in parallel. And then I can compare the outputs. And that worked out fairly well. Now, sometimes what will happen, then all you have to do is when you're doing the comparison, you've got to normalize the old and the new. So, for instance, if the old did the temperatures in centigrade and the new does temperatures in Fahrenheit, when you compare the two, you've got round off error. That's consideration as well. I'd say that the most effective thing to do in that case is find a way to make sure that you've got, and I was lucky in the fact I was able to run the old in such a way so that I could do code coverage. And if I can run the old, run through a bunch of cases that give me 100% code coverage or high 90s code coverage, says, okay, now that means that my test suite that I just ran engages everything the original coders were worried about, their requirements and their bug fixes. If I've got, okay, that gives me a test suite that I can run the old against, run the new with that exact same data, and then the comparison, that worked out extremely well. So I was very pleased with how that project worked out. That's where I was talking about F# being fun. Great tool out there called FS-Check, which is an F#, a .NET port of Quick Check from the Haskell space. Quick Check is an amazing tool. If somebody puts a gun to your head and makes you do end-to-end testing, we'll learn how to use Quick Check.
Okay. Like when you're talking about rewrites and refactoring and things like that, more often than not, have you found yourself on team rewrite or team refactor more often?
Rewrite, because what happens is that getting people to drink the test-driven development Kool-Aid is sort of hard. And the thing is that when you first start doing test-driven development, your tests are not going to be very good. One of the things about writing bad unit tests is the bad unit test will capture things that are irrelevant to the software under test. I had something where basically I was rendering documents, and the documents would be rendered using into, say, a PDF. I had a PDF compare tool. Great. The trouble is that I would have unit tests that would fail if the graphics engine varied. And oh man. And so what I was doing is just like trivial library changes would cause unit tests to fail. Why bad baselines? Because I had to get smarter about building baselines in my unit tests. And what we had to do then was make sure that when a test fails, it fails for the right reason. And maybe you don't do a bitwise compare of two things, but rather you do a compare that just looks at only the relevant features of what's in it. And every test, you may have two tests that do the exact same thing, but in the assert part of the two tests, because in the arrange and the act has been the same, but in those you have different concerns. So what happens is I'm going to look at this feature, and then I'm going to look at that feature. And let's suppose you have the test that generated two JSON strings representing a data structure, a key data structure. Not every part of that data structure has to be compared with every other part. So what you do is you just circle in on just the fields that you're interested in and do that and make your comparator smart enough to only look at the things that are relevant to the concerns of that test. And that's the trouble is you can easily have a lot of tests that you forget why they're there. You've got to be able to say, you've got to curate not just your code base, but also your unit test suite. So what happens is you know why that test is there and you know what that test's trying to assure yourself of. And obviously I'm talking about in the desirable case. Reality is going to be much more messy.
With all the third-party software tooling that we have available today, do you think it's less complicated to manage the long-term maintainability of software now than it was, say, 20 to 30 years ago?
It's more sophisticated. I don't know if it'd be more complicated. So in other words, what happens is it harder to tune up a car when you've got a sun diagnostic system that's got a computerized, it's basically talking to the computer inside your car? Or is it easier to tune up your car when all you're doing is you're turning a dial on the distributor? You're tweaking the dial for the timing on the distributor. Mm-hmm. That's something that my dad would do, but mechanic doesn't do because we're not dealing with distributors and points and stuff like that. So what happens is the technologies, to a certain extent, you have to be, if you're going to do things with stone knives and bear skins, you're going to have to be awfully smart. You got the new tools. One, you have to understand those tools. And then two, you got to figure out how to leverage them.
What's the best lesson you learned early on in your career that you find yourself still applying it?
I would say humility. Thing is that we're not gods. Clint Eastwood, Magnum Force, a man's got to know his limitations. A developer's got to know his limitations. A tester's got to understand his limitations. When you've got, say, 10 microservices chained in a little daisy chain, and each of those 10 microservices can exist in 10 states, how are you going to do end-to-end testing on that system? It's going to be 10 to the 10th power. That's more than any human can ever hope to test. So what you have to do is that you've got to recognize your limitations, recognize you can't exhaustively test those things, and then put your focus where you can get your assurances. In other words, every unit test should work only on the software under test and not expand beyond those borders, and should mock everything outside it. That's a recognition of your limitations. You can't do everything. You can only do the one thing. Make that one piece of code crystal clear and right. Do that for every piece in itself. And then instead of trying to do end-to-end integration tests, do pairwise integration tests. Because think of it, if I posited this fictitious 10-step microservice architecture, with each thing being 10 things, you can't do 10 to the 10th power tests. But what you can do is there's 10 states of the first one and 10 states in the second one. You can think in terms of that 100 different states and come up with a reasonable set of unit tests. I should say integration tests. But that's just pairwise integration. And then just do that as a chain and walk your way down the way.
Given that you've been in a senior level role with engineering teams for a number of years, what do you find is one of the more common mistakes you see when, say, more junior or kind of earlier in their career developers approach technical debt?
Well, I think the first thing is that the assumption is that the guy that wrote this original thing was an idiot. The guy that wrote the original thing was not an idiot. I've been on teams long enough so that I was the idiot. In other words, I'm looking at code I wrote 6 months ago. I'm looking at code I wrote 6 years ago. And I'm thinking, boy, to a certain extent, I was an idiot, and I've learned some things. But a lot of the times what happens is that the concerns that I had at that time, I've forgotten. And what happens is you got to have a respect for the guys that came before you and realize they weren't idiots. If anything, they missed out on the opportunity to put unit tests to verify their thinking. Because you can get your thinking right, you can nail it down, you can have everything right, and the environment changes out from underneath you. And then suddenly something that was perfectly appropriate has changed because the outside environment or the use case has changed. So what you should do is you should encapsulate those assumptions that you've made in unit tests. Make it very clear that this is the context in which this software should run, and somehow assert that in such a way so that if that assumption about the context within which software runs, if that assumption is falsified, you should have something that raises its hand and says red or yellow.
That kind of speaks back to a little bit to earlier when you were talking about rewrite projects or what have you. There's always that kind of scapegoat being the mysterious previous developers that used to work on this project. It's always a thing that we talk about even within my own team and trying to figure out, like, we inherit projects more often than not. When we do that, it's like making sure it's an education thing. Like, let's be very mindful and empathetic and have some humility to know that they were working with a different set of constraints than we have the privilege of understanding because they're not here to share their perspective. They might not even remember, or it could have been us too, that previously worked on the code base. We know that we're going to look back at our own code that we're writing today and be like, what were we thinking given what we know now and in that future world, whatever that will look like. So the fact that the software is malleable is a good thing, but I worry about when people just find that scapegoat a little too easily. I think it's easy to talk about the boogie person that, whoever wrote that stuff and made their life hell. So that was not their intention, I'm sure. So
the real enemy is the technology. The real enemy is Murphy. It does require a little bit extra work to Murphy-proof your code. And oftentimes your manager doesn't appreciate the fact that you've spent a little bit more time to Murphy-proof your code. We're in an environment now where your manager will understand that you've got to write unit tests. Yeah, that's the big deal. So I would circle back to something we talked about earlier than what I've been wanting to say. If you are tasked with not a complete rewrite, but just a refactor, your very first step, or if somebody just hands you a code base, So you bought a company and you got their code, and the code's doing great things for them, and you've just inherited. You've got to take ownership. The monkey's now on your back. So the first thing you should do is look at the unit tests. Do they exist? If they don't exist, start writing them. Because what happens is those unit tests are going to have your back. Because if you don't have the unit tests, you're going to be afraid to touch your code. And you're going to have that good suite of unit tests that cover all your concerns and that you understand why those unit tests are there. Then what you can do is you can say, okay, I'm going to make this change. And if I screw something up badly, the unit test will have my back.
I'll be back with my interview with Steve in just a moment. Hi, it's me, Robby. I wanted to thank you for listening to the Maintainable Software Podcast. I'm not sure how you came across the podcast, but I'm glad you did. But I like more people to find it as well, and I hope you would too. So if you're finding these conversations valuable, please consider sharing it amongst your peers and/or writing a review on Apple Podcasts to help spread the word. Also, if you have a good story or two to share about ways to improve the long-term maintainability of software and might be interested in being a guest on the show, please get in touch with me at Robby with a Y at maintainable.fm. And now back to our interview with Steve Poling. Do you feel like sometimes software written within a company, the health of the code base or maintainability and the quality is reflective of the communication and the culture of the company itself? Or do you feel like it's more of just depending on the developers themselves?
I think Conway's law was rock solid. The shape of the software will accommodate itself to the shape of the organization that developed it. That's Conway's law, and I think that holds in larger organizations. In smaller organizations, where you've just got one team that's got their hands in the code base, that'll be less the case. Then it'll be a matter of the personality of the individual contributors to the code base. At one time, I thought it was a good thing that I could say, oh, that's Ed's code, or, oh, that's Rob's code, because I know that Ed likes to have 60 character variable names, and I know that Rob likes to do something else. But really, you should have a certain uniformity of code. So I think in a more mature organization, you don't see a lot of variation. You don't see Rob's code or Ed's code or Steve's code.
I agree. I think that was one of the liberating things about every project that I would work on that someone else had worked on. It felt like I had to understand not only what tools that they had used, but what their preference and style was. This is usually like projects that only a few developers had ever worked on. It was always a struggle to how is this really pieced together? And it wasn't until like some frameworks, things like Ruby on Rails, because I'm in the web development world, where someone outlined a framework and a pattern for how we're going to do this, and they just bake the opinions into it. If you follow this, we're making a bunch of decisions for you. But if we all follow these set of decisions and kind of work in the same conventions, that we'll all be better off and we can worry about more important things. And I remember that being really complicated. It was interesting at first for me, where I was like, I think I kind of like this, but I was all like, but I want to use this other thing. But then I realized 3 or 4 years later that my opinion of that thing that I thought I should do differently because of something I'd picked up, I didn't have that same sort of strong preference anymore. I was like, no, I can follow what the community is going for. If we're all working together, makes my life easier. And it definitely has helped me, fast forward 16 years or so. And it's like, we take over projects, and typically most projects follow a sort of set of conventions. That gives me a step up of being like, I can jump in and help out on an existing code base pretty quickly now, because I know where to find stuff. I know how things should be done. And when people deviate for that causes problems. We can help identify that quickly because it'll stand out being kind of odd. I feel like that's been a good thing for the industry to see a lot more conventions and practices. And I think open source helped a lot of that.
Well, one thing about open source is suddenly what happens is if I'm going to commit my code changes and only I'm going to see them, who knows how evil it'll be. But if I know that you're going to look at the code, I'm going to make sure that I'm not saying something embarrassing. That embarrassing bad thing that I shouldn't do, if I know you're looking at it, I know I'm going to catch flack for it. Especially nowadays, if I'm going to put something into a pull request and I'm going to ask you to look code before we commit it. Oh, suddenly with more eyes, code becomes much less idiosyncratic. And I think one of the things that move away from idiosyncratic code is that a very powerful thing you just mentioned, which is, I don't know where this is, but I know where to look, even though I don't know anything about the code base. That's very powerful. And you get that by observing patterns and by saying, okay, if the patterns book, the Gang of Four book, I think that was a very important book in terms of the development of our profession. That whole means of thinking.
That's great. A couple just final questions for you. Are there other aspects of technology that you're finding that you're really curious to learn more about in the near future?
I'm noticing that there's a lot of language developers following each other's taillights. One guy will say, gee whiz, let's do type inferencing. And then the other guy says, yeah, let's do generics. And yeah, let's do, where what happens is now I can create a variable type. I can say, let X be something. And if I say, let X equals 42, oh, it's an integer. If I would have said if Y equals red, you would have known it was a color. So the thing is by just having the compiler infer the type from the usage, I think that's really good. By just saying, let variable equal whatever, let the compiler figure out what it is. There's a lot of wasted brain power that went into writing in early Java or some of these other languages that were strongly typed, where you had to think, what am I going to do for this type? Did I get the type wrong or something like that? And having the compiler go and catch so much bad thinking by having it infer the type that you want just by the way that you're using the code, and then have it go and say, you can't really add 4 to color, or you can't really add 5 to Steve, or you can't subtract, name from database. It's like, oh, that's really good. I like that. I like the fact that the tooling is getting so much better in terms of inferring types and enforcing types. Well, one of my books on my shelf is programming in types. So I think that's one of the things I'm interested in.
And where can people learn more about you online?
Oh, I'm on LinkedIn, and I'd say probably that's the best place to look for information about me.
Well, thank you so much for joining us on Maintainable, Steve. It's been a pleasure chatting with you about your vast experience in the industry, and I wish you luck with learning more about type languages in the near future.
Well, very, very much. Thank you. It was a very enjoyable conversation with that. Thank you very much.